Yes. So hello everyone. Now my screen is visible.
Yes, sir.
Okay. So this is lecture 3 on computer networks. I think again gone.
Yes, sir.
Yeah. Now I think it's fine. So hello everyone. This is lecture 3 on computer networks, and now we are going to start physical layer. Okay. So physical layer is not that much important for gate, but still we will study that so that you get more clarity about the basics of computer networks. Okay, so we should have a little bit idea. We will not dig deep into this topic. This layer is very huge, okay, very vast, but we will simply touch few topics which are very important, and you can consider that one or two questions might be asked. Okay, so let me start the topic. So I will start from the very basic, from scratch I will start. Okay, so how data is transferred. Okay, data is transferred via physical media. Data is transferred via physical media like wire and all, in the form of what? In the form of signals. So data is transferred via physical media in the form of signals. Okay, yeah. So types of signals. So now we will study what are the types of signals. So broadly we will consider signals are of two types. One is known as digital signal and another is known as analog signal. Digital signal means if we consider strength versus time graph, signal strength versus time graph, then how it look like? It will look like this. Okay, so you can consider any two time interval. For example, this is t1 and for example say this is t2. So number of times signal has changed, that is finite. Okay, or you can say one so see, for example, you can consider this plus 5 volt and you can consider this as minus 5 volt. So plus 5 and minus 5, only two values are there between t1 and t2. Okay, so we can say that we have discrete values of strength between any two instance of time. Okay, that is known as digital signal. Digital signal means discrete value of strength between any two interval. Discrete value of strength between any two interval. Okay, so between any interval, na, we should say like this, between any, yeah, between any two interval, no problem. Okay, so that means you have taken just two time slot, and or you can say any two times you have taken, and value is discrete. Okay, only two values, plus 5 and minus 5. What is analog signal? Analog signal is, see, this is strength versus time graph, so it is just like a sine wave. So now you consider this time as t1 and this time as t2. So what will be the signal strength? It is changing continuously with time. Are you getting it? It is changing continuously with time. This is strength versus time graph. So t1 and t2, so infinite values. Okay, so here it is changing continuously with time. That is known as analog signal. So signal strength changes continuously with time. Signal strength changes continuously with time. Okay, that is the basic meaning of analog signal. Okay, so now we will study the next category. You can take snapshot. I will jump to the next slide. So please be active. We have to cover many topics. Actually, this subject is very vast. If we keep on delaying the things, then we have to take around 90 to 100 hours to complete this subject. But we cannot afford that. Okay, so please be active. Done? Okay. So first category was digital and analog. Digital means like this. Okay, it between any two interval, you take any two interval of time, you will get discrete values. But here continuously changing. That is analog. Okay, so another category of signals is Another way to categorize signal is periodic, aperiodic. Periodic and aperiodic. Periodic means there is a particular pattern which is repeated again and again, like this. Okay, same pattern is repeated again and again. Or in digital case, you can consider this as a pattern. One pattern, now same pattern repeated, now same pattern repeated, and so on. Okay, like this. So that is periodic. So periodic signal can be either analog. Okay, so this is periodic analog signal and this is periodic digital signal. Okay, so periodic can be of two types, periodic analog and periodic digital. So these are the examples. So what in one line, what can I say periodic means? Pattern is repeated, same pattern repeated again and again, same pattern repeated again and again. Okay, so for example here the same pattern is repeated again and again, here also. Okay, yeah. What is aperiodic? Obviously pattern is not repeated. So again it is of two types, periodic aperiodic analog and aperiodic digital. Aperiodic analog, like you consider this type of signal and so on. Okay, so nothing is repeated. Aperiodic digital, like this. Okay, and then somewhere like this and so on, something like this. So it should be straight line. Okay, because we have to consider discrete intervals of time, na? Like this, something like that you can make it. Okay, so I just want to give idea. Okay, so aperiodic digital means no pattern is repeated, aperiodic analog means no pattern is repeated, and so on. Okay, so now we will study. So take snapshot, I will jump to the next slide. Hmm. Okay, so now we will give detailed study of analog signal and then we will study periodic digital signals. Okay, so first we will study analog signals. Analog signals. So analog signals again can be of two types. One is known as simple analog signal and another is known as composite analog signal. Okay, and we will study periodic analog signals only. Forget about aperiodic. Periodic analog signals is of two types. Okay, are you getting it now? So first was signal is of two types, digital and analog. Now next category was signal can be of two types, periodic, aperiodic. So periodic can be digital analog and aperiodic can be digital analog. Now we are studying periodic analog signals in detail. So periodic analog signals can be simple or composite. Simple means only one sine wave is there, like this. Okay, and it is repeating again and again. Composite means multiple sine waves are there. For example, this is one sine wave, this is another sine wave, this is another sine wave, and so on. This is composite. So one sine wave. Why it is known as sine wave? Because sine function graph is like this only, sine theta. I think you already know. And this is multiple sine waves. Multiple sine waves. Okay. Yes. So now we will study terminology related to simple analog signal. Take snapshot. I will jump to the next slide. Okay. Next is simple analog signal. Simple analog signal study we are going to do, and three basic terms. Three basic terms. The very first term is amplitude. Next is period or frequency, and the third is phase. Amplitude. Amplitude means okay, here let me do it. See this, for example, I have made a simple analog signal like this. Okay, so amplitude means you just measure strength of signal. This is strength versus time graph, na? So you just measure strength of signal at any instant of time. Okay, like this, T2, T3, okay, or you consider T4, So at T1 it is 1 volt, at T3 it is 2 volt, at T2 it is minus 1 volt. Okay, so and so on. So amplitude means simply you measure strength of signal at particular instant of time. At any particular instant of time, what is the strength of signal, that is known as amplitude. So do not consider that this is peak amplitude. Do not say that this is amplitude. Okay, this is also an amplitude. This is also an amplitude. This is also an amplitude, and so on. Are you getting it? So do not say this is only amplitude. No, this is peak amplitude. Okay, so that is the maximum amplitude. So what is amplitude? Amplitude means measure of strength of signal at particular instant of time. Let me write it. Amplitude means let me write it with red color, blue. Measure of strength of signal at particular instant of time. Okay, so what is the unit of amplitude? What is the unit? Unit can be either volt, watt, or ampere. I think you already know potential difference, power, or current. Okay, so these are the units. Now in physics we have studied that. So amplitude means measure of strength of signal at particular instant of time. That is amplitude. So at any particular time you just measure the strength. That is your amplitude. Okay, next definition is important. Period or frequency. So what is the period? If we say for example, I consider this time. Okay, so if I say this is 1 second, if this is 1 second, so what is the time period? Time period means time taken to complete one cycle or pattern. Okay, so this is the cycle, na? So so 2 cycles have been completed in 1 second. So obviously this is 1/2 second, this is 1/2 second. So this is the time period. Time period means time taken by signal to complete one cycle. Okay, time period means, as the name suggests, time taken by signal to complete one cycle. Time taken by signal to complete one cycle or pattern. Cycle or pattern, one and the same thing. Okay, so here time period is 1/2 second. So t is equal to 1/2 second here. And why I'm considering 1/2? Because I have assumed that this is 1 second. This entire time is 1 second. Okay, what is the frequency? What is the frequency? Frequency means number of cycles completed per unit time. Number of cycles completed in 1 second, you should say properly, in 1 second. Number of cycles completed in 1 second. That is known as frequency. Okay, so or in per second, you can say number of cycles completed per second or number of cycles completed in 1 second. So here what will be your answer? 2, because 2 cycles have been completed. So are you getting it? So obviously frequency is equal to 1/t or t is equal to 1/f. I think you already know. And what is the unit of frequency? Unit of frequency is hertz, HRZ, hertz. Okay, so take snapshot. I will jump to the next slide and I will give you more insights of this.
Copy, sir.
Okay, so now frequency. So units are very important, frequency and time. If frequency is in hertz, then your time period will be in seconds. If frequency is in kilohertz, time period will be in millisecond. If frequency is in megahertz, it will be in microsecond, and if it is in terahertz, then it will be in nanosecond. That is more than sufficient. Okay, so so let me write it. 1 hertz, 1 second. 1 kilohertz, 10 to the power 3 cycles per second, or 10 to the power 3 hertz. So obviously you will get 1 millisecond, that is 10 power minus 3 seconds. 1 megahertz, that is 10 to the power 6 hertz, or you can say 10 to the power 6 cycles have been completed per second. So obviously I cannot make 10 lakh cycle per second, and I cannot make a diagram and show you. You can imagine that thing. So in 1 second, 10 lakh times pattern has been repeated, and that is general frequency, 10 power 6 for megahertz and so on. Okay, so 10 to the power 6 hertz. So it is 1 microsecond, that is 10 to the power minus 6 seconds. And these are very important terms. Okay, so you have in computer architecture also you will study them. So like you say na, sorry, I think I have done a mistake here, sorry for that. It should be gigahertz. Okay, 1 gigahertz is 10 to the power 9 hertz, and that is 1 nanosecond. And 1 terahertz, that is 10 to the power 12 hertz, and that will be 1 picosecond. Yeah, so it will be 10 to the power minus 9 second. It will be 10 to the power minus 12 second. Okay, yeah, so this table is very important, and you will use that in computer architecture also. So in computer architecture, I think you know, you say your my CPU is 1 gigahertz. So what do you mean by 1 gigahertz CPU? 1 gigahertz CPU means in 1 nanosecond or 10 to the power minus 9 second, 1 clock tick will be done. So in 1 clock tick, instruction will be fetched. In next clock tick, instruction will be decoded. In next clock tick, instruction will be executed. So roughly in 3 nanosecond, you have executed 1 instruction on the CPU. If your CPU is 1 gigahertz. But if you say my CPU is 1 megahertz, then you will say in 1 microsecond, I have instruction is fetched. In next 1 microsecond, it is decoded. In next microsecond, it is executed. So 3 microsecond instruction has been executed, and here in 3 nanosecond instruction has been executed. So obviously 1 gigahertz processor is 1000 times faster than your 1 megahertz processor. Like this you will analyze in computer architecture. Are you getting it? Yes, any doubt?
Yes, sir. Yes, sir. No, sir.
Okay. So frequency 1 hertz, time is 1 second, 1 kilohertz, 10 power 3 hertz, that is 1 millisecond, 10 power minus 3, 1 megahertz, 10 power 6, so 1 microsecond, 10 power minus 6, 1 gigahertz is 10 power 9 hertz, that is 1 nanosecond will be time period, 10 power minus 9, and 1 terahertz is 10 power 12 hertz, that is 1 picosecond, 10 power minus 12 seconds. Okay. So I think you have got it. This is very, very important terminology which you should remember. Okay. So this is all about frequency. So now let me give you a small numerical so that you get more clarity. So time period of signal we want to find. We want to find the time period of signal, and frequency given is 5 megahertz. 5 megahertz is the frequency, and what is the time period? So properly you should do. So what will be the time period? You will simply say 1 by 5 for megahertz. It is microsecond. So you will say 1 by 5 microsecond is my answer. So no need to worry. So so the basic thing is they just want to check you know the these units or not. If you able to know the units, you will get answer very easily. 1 by 5 microseconds. So obviously you can say 1000 by 5 nanosecond. So that is 200 nanosecond is the answer. So like this you have to calculate. Any doubt here? Yes, please let me know.
सर वो नैनोसेकंड में कन्वर्ट कैसे किया था सर?
Okay, so see this microsecond is 10 to the power minus 6, nanosecond is 10 to the power minus 9. So what is the gap? 1000 na?
Yes sir.
So if you have any doubt, 10 power minus 6 upon 10 power minus 9, you will get 1000. Okay, so that's what I have done. So microsecond to nanosecond. So 1000 microsecond is 1 nanosecond na? Are you getting it?
Yes sir.
Okay. Yeah, so so that's it. Okay, so I think I have given opposite explanations. So 1000 nanosecond is 1 microsecond. You should say like this. Okay, so 1000 nanosecond is 1 microsecond. Is it okay na? Because 1000 into 10 power minus 9, so that is 10 power 3 into 10 power minus 9, that is 10 power minus 6. So 10 power minus 6 is 1 microsecond. Any doubt here?
No, sir. Clear, sir.
So 1 by 5 microsecond was the answer. So so 1000 by 5 nanoseconds I have converted, so it will be 200 nanoseconds. Okay, so next question. So they can say time period of signal is 100 nanosecond. Okay, and they are asking the frequency. What is the frequency? So you will immediately say 1 by 100 gigahertz. So nanosecond gigahertz. So 1 by 100 gigahertz. So you will simply say it comes out to be 10 megahertz. Why 10 megahertz is coming? Because see this, 1 gigahertz is 10 power 9 hertz and 1 megahertz is 10 to the power 6 hertz. So 1 by 100 into 1 gigahertz is 10 power 9. So it comes out to be 10 power 7 hertz. So it comes out to be 10 into 10 power 6 hertz, and 10 power 6 hertz is megahertz. So 10 megahertz. Yes, any doubt? Please be
No, sir.
active. Please respond me. Okay, okay. Yeah. So take snapshot. I will jump to the next slide. Done.
Done, sir.
Okay. Now see this. If I make a strength versus time graph like this, so they can ask what is the time period and what is the frequency. So frequency means number of cycle completed per unit time. So in 1 unit of time, how many cycles are completed? Big zero cycle is completed. Oh, sorry. So big zero cycle is completed. So frequency will be 0. Are you getting it? Number of cycles are completed 0, na? No cycle is there. So what you have completed? Nothing. So frequency is 0. So what will be the time period? 1 upon frequency, that will be infinite. Okay. So you can consider, you can say, sir, yeah, we need infinite time to complete 1 cycle. Okay. So this is nothing but your DC current. So for DC current, they can ask direct current, na? So for DC, DC, that is direct current. So for DC, it will be, frequency will be 0 and time period will be infinite. Any doubt? Okay, please take snapshot. I will jump to the next slide.
Done, sir.
Okay, so next definition. So how much, see, amplitude we have covered, period we have covered. So next definition is phase. So let me start the phase. What is phase? Phase represent position of waveform, position of wave with respect to time 0. Position of wave with respect to time 0. So for example, I have made a wave like this. So what will be the phase? Phase shift will be 0. We will say phase shift. So phase shift is 0. Okay. Why? Because at time 0, nothing has been shifted. So if I say I have shifted 1/4 of the wave. Okay. So like this. Are you getting it? I will make the wave like this now because I have shifted 1/4 of the wave behind. So it will be like this. It will go up like this. Okay. So this is phase shift 90 degree. Phase shift pi by 2, or that is 90 degree. Pi by 2 radian or 90 degree. Now if you shift phase, say half of the wave is shifted. For example, you say like this, half of the wave is shifted. So now our new wave will be like this. So here we will say phase shift is equal to pi. That is equal to 180 degree. Pi radian or 180 degree. Okay, and the next is 3/4 of the wave is shifted. If you say 3/4 of the wave is shifted, so like this. So now I will start from here and go till here. Okay. So here phase shift will be 3 pi by 2 or 270 degree. And now if I shift entire wave behind, so what it will look like this. So what you will say? Phase shift of 2 pi. That is 360 degree, and it is clearly same as this. So phase shift of 0 degree, that is equal to phase shift of 2 pi degree, so 2 pi radian, and that will be equal to 360 degree. So this is the phase. So position of waveform with respect to time 0. So a very small numerical they can ask. So they can give you a sine wave is offset. A sine wave is offset pi by 6 or 1 by 6 of a cycle. If sine wave is offset 1 by 6 of cycle with respect to time 0, with respect to time 0, so what is the phase? So one cycle, if it is one cycle, then phase shift is 360 degrees, 0 degree or 360 degree. So if 1 by 6th of a cycle, then 360 divided by 6, so 60 degree. So 60 degree means pi is 180 na, so pi by 3 phase shift, pi by 3 radian. Are you getting it? So if you do not know, 360 degrees 2 pi na. Okay, so 60 degree will be what? 2 pi by 360 into 60, so pi by 3. So if you have any doubt, then I will explain more precisely. Otherwise, I will shift to the next slide. Please let me know if anybody is having any doubt here.
Understood, sir.
Okay, no doubt?
No, sir.
Okay, so please take snapshot. I will jump to the next slide.
Done, sir.
Okay. So one more basic term is coming. Rather, it is not a basic property. It is derived property. Three properties we have studied. 3 basic terms: amplitude, period, frequency, or phase. So next is wavelength. Wavelength. Okay, what is the wavelength? Wavelength means, see, we are considering strength versus time graph now. So if you considered strength versus distance graph, then you will get your wavelength. So what is the wavelength? See, this will be the wavelength na? So distance occupied by one wave on transmission media, that is wavelength, represented by delta. Oh, sorry, lambda, represented by lambda. So what is wavelength? Distance occupied by one wave on transmission media. Distance occupied by one wave on transmission media. Okay. So you can simply say, if this was strength versus time graph, so you will say this is time period na? Are you getting it? So if I say in place of distance it is time graph, strength versus time graph, then you will say this is your time period. So now if we consider if we say strength versus distance graph in place of strength versus time graph, then time period will be nothing but your wavelength. Can I say like this?
Yes, sir.
So same thing. I'm not writing it just to save the time. So you can take snapshot and I will give you an idea, or rather you already know these things. Not what distance is what? Distance is equal to speed into time. Okay, so distance is what? Lambda. Lambda will be equal to speed. Speed of light we will consider 3 into 10 power 8 meter per second. Okay, and time they will give you whatever time they will give. So you can find the wavelength. Okay, time period they can give you, or you can say lambda is equal to c upon f also, because time period is 1 upon f. So like this you can find. So I will solve a very small numerical just to give you clarity. Take snapshot. I will jump to the next slide.
Copy, sir.
So here in these numerical, they just want to check your do you know the units or not properly. Okay, so they will say like this. So time period is given as 3 microsecond, and they are saying what is the wavelength. So if nothing is given to you, so you will consider speed of light as 3 into 10 power 8 meter per second. That is vacuum speed na. If they want to give, then they can give like 2.4 into 10 power 8 meter per second and all. Whatever they will give, you can take. If nothing is given, by default you will take this. That is speed of light in vacuum by default. Okay, if they give explicitly given in numerical, then you will take this. So now I'm taking solving it by this. Okay, because our calculation will be easy. So what will be our answer? So distance is equal to speed into time. So speed is what? 3 into 10 power 8 meter per second multiplied by 3 microseconds. So see this per second and here microsecond. So obviously we will convert it into seconds. So 10 power minus 6. So what it will be? 9 into 10 power 2. What will be the unit? Do not say 9 into 10 power 2. You will say meter. Okay. So what will be your answer? 900 meter or 0.9 kilometer. Okay, units are very very important. So they will these questions will be asked just to check you know units and all or not. That's it. Take snapshot. I will jump to the next slide.
Done, sir.
Okay. So next they can ask find the wavelength. Find the wavelength if frequency is 600 megahertz. So and they have not given speed of light. So speed of light you will take it as 10 power 3 into 10 power 8 meter per second. So C is 3 into 10 power 8 meter per second. Frequency 600 into 10 power minus 6 hertz. So it will be per second. So here you will get second. So second will be cancelled. I think these are very obvious things you know. So final answer will be what? So what we will get? Sorry, 600 to 10 power 6 na. Megahertz is 10 power 6. Sorry for that. 600 into 10 power 6. So, so 3 was there. So 3 into 10 power 8 divided by 6 into 10 power 8. 10 power 8, 10 power 8 gone. 1 by 2. So 1 by 2 units should be proper. Meter. So 0.5 meter. Or you can say 50 centimeters. Okay. Take snapshot. I will jump to the next slide.
So 50 centimeters?
Yeah, 1 centimeter, 1 meter is 100 centimeters, na?
0.5 it is. Yes, sir.
Multiply by 100, 50 centimeters.
Sir.
Okay, take snapshot. I will jump to the next slide.
Okay, sir.
Okay, so now simple analog signal is completed. Now we are going to start composite signals or composite analog signal. Composite analog signal. So what was the and we will study only periodic. Composite periodic analog signal. Okay, yeah. So so periodic means some pattern will be repeated again and again. Okay, so what we will say. So here composite means multiple sine waves will be there, na? So one sine wave is this, another sine wave. Okay, it is not that good. Like this, and another is say 1, 2. Okay, so like this. So this is an example of composite periodic analog signal. So I have shown you this is completely messy kind of thing, na? And what I have drawn, strength versus time graph. So it is completely messy. Okay, so if I consider this as 1 second, if I say this is 1 second, so then what will be the frequency? So frequency of this this one. So let me draw it with the black color. This color frequency 1. Okay, why 1 hertz? Because 1 cycle is per unit. Then blue one is 1 and 2. So for black one it is 1. For blue one it is 2. For red one 1, 2, and 3. So if I make strength versus frequency graph, how it will look like? It will be 1, 2, and 3. It is much better option. So composite analog signal will be represented like this. This is much better option. So strength versus frequency graph is much better. So 1, 2, and here 3. Okay, so they can so few terms we can introduce here. So what are the term? First term is frequency spectrum. Take snapshot. I will go to the next slide.
Done, sir.
Okay, so frequency spectrum. Frequency spectrum. Frequency spectrum means collection of all component frequencies a composite signal have. Okay, so collection of all component frequency a composite signal has. Composite signal contain. You can think like that. So for example, for the previous example of a frequency spectrum will be 1, 2, and 3 because 1 hertz, 2 hertz, and 3 hertz. Okay, so for the previous example, frequency spectrum was this. Okay, next is bandwidth. Bandwidth is width of frequency spectrum. Width of frequency spectrum. So width means maximum minus minimum. So f max minus f min. So 3 minus 1, 2 hertz. So 2 hertz is the bandwidth. Are you getting it? Any doubt here?
No, sir.
Okay. So now let me jump to the next slide and I will solve a very basic numerical. So let me jump to the next slide. So they are saying question is a periodic signal is decomposed into 5 sine waves of frequencies 300, 500, 100, 900 and 700 hertz, and they are asking bandwidth. So frequency spectrum, if they ask, you will write it as it is because it is nothing but collection of all the frequencies. So what is bandwidth? Maximum minus minimum. Maximum is 900, minimum is 300. So answer will be 600 hertz. Units are very important. Hertz they are saying, so you will write hertz. 600 hertz is my answer. Oops, sorry. Minimum was 100. So 800 is the answer. 800 is the answer. Okay, so 900 minus 100, that is 800 is the answer. That is the bandwidth. So I think you have got the point. Okay, so if I say, so now they can twist the question and they can ask, what is the bandwidth of simple analog signal? Simple analog signal. Simple analog signal is having only one frequency. Maximum is same, minimum is same. So we have to say bandwidth is f max minus f min. Now both are same for simple analog signal because it is simple. So answer will be what? Big zero. Are you getting it?
Yes, sir.
Okay, so this is the actual meaning of bandwidth. So the one which you think that bandwidth is 5 Mbps, 4 Mbps, that is a different term. I will come back to it later. But this is the actual meaning of bandwidth. Bandwidth means maximum minus minimum frequency, or you can say width of the frequency spectrum. And bandwidth is measured only for composite signals. It is not for your simple signals, because simple signal bandwidth will be 0. Okay, so actual meaning of bandwidth, now I think you know what is the actual meaning of bandwidth. Bandwidth simply means, see this I have written, width of the frequency spectrum, and bandwidth is for composite signals only. Bandwidth is for composite signals. Okay, yes, any doubt here? Okay,
No.
so take snapshot. I will jump to the next slide.
That's all.
So this is the story of analog signals. Now we will study digital signals. Digital signals. So digital signal is, I think I have told you, discrete values. Okay, discrete values with respect to time. Okay, so for example, like this. Yeah. So this is an example of digital signal. Okay, so for example, I will say that this is logic 1, this is logic 0, this is logic 1, this is logic 0. Strength versus time graph I have made. Are you getting it? So means presence of current. If current is present, you will say logic 1. Okay, or rather positive side. If it is negative side, you will say logic 0. Positive side 1, negative side 0, like this. So you can consider this as 5 volt, you can consider this as minus 5 volt. Okay, 5 volt and minus 5 volt. I think you have got the point. Okay, yeah, so now I will introduce the terms. Just like analog signal, we will say see simple terms here. So first one is bit interval. Okay, next is bit rate, and next is bit length. Bit interval means how long a bit lasts on transmission media. If you try to remember, I have given this definition in functions of physical layer when I was discussing in the first lecture. I have told you bit interval means how long a bit lasts on transmission media. Okay, bit interval means how long bit lasts on transmission media. So for example, if I consider, let me use another color. If I consider this as 1 second. Oh, till this point, yeah, this is 1 second. If I say this is 1 second, so bit interval will be what? How long bit lasts on transmission media? So 1/4 second. 1/4 second. Okay. So 1/4 second, 1/4 second, 1/4 second, 1/4 second. So how long bit lasts on transmission media? 1/4 second. So I think now you can link. It is just like your time period of analog signal. Are you getting it? Time period of analog signal. Same. Okay. Yeah. So terminology is different. Actual concept is same. Bit rate. Bit rate will be what I have told you. Rate means per unit time. So number of bits transmitted per unit time. Number of bits transmitted per unit time. So what will be the answer? 4. 4 bits are transmitted per second. So we'll say 4 BPS is the bit rate. So how you just like your frequency. Are you getting it? Yeah. Any doubt? Please let me know.
No, sir.
No, sir.
Okay, frequency of analog signal. Okay, so this is frequency of analog signal. Okay, and then the last is bit length. Bit length is distance occupied by 1 bit on transmission media. Distance occupied by 1 bit on transmission media. If you try to link, it is nothing but your wavelength. Wavelength of analog signal. Okay. So lambda will be speed in distance is equal to speed into time and so on. You can consider that. Okay. So let me solve 1 or 2 numericals just for the completion's sake. Take snapshot. I will jump to the next slide.
Done, sir.
Okay. So now question they are saying is find the bit length. Bit length if bit rate is 6 Mbps. So I think I have not written again and again. It will simply waste our time. So Mbps means 10 to the power 9 and so on. Okay, let me write it. No problem. Let me write it. So bit rate. So it can be either in BPS or it can be either in KBPS, Mbps, GBPS, TBPS. So 10 to the power 0. 10 to the power 3, 10 to the power 6, 10 to the power 9 and 10 to the power 12 BPS. Any doubt here?
No, sir.
Okay, so very basic terminology which you should remember. Okay, so 6 Mbps. So a bit length to find. Bit length is lambda is equal to speed into time. So speed nothing is given, so we will take 3 into 10 to the power 8 meter per second. So per second, and bit rate is 6 Mbps. So 6 into 10 to the power 6 bits per second. Okay, BPS. So per second got cancelled. Okay, so what will be the you can say wavelength? So it comes out to be 1/2 into 10 power 2, that is 50 meters. Okay. So 50 meters is the wavelength. Or you can say wavelength is the analog signal term, bit length will be digital signal term. So bit length will be 50 meters. So for 50 meter, 1 bit will be transmitted on the media. Is it okay?
Yes, sir.
Take snapshot. I will jump to the next slide.
Copy, sir.
Next question is they want us to find the bit rate. What is the bit rate if 1 bit lasts on transmission media for 1 microsecond? if one bit lasts on transmission media for 1 microsecond. Okay, so they want to find bit rate. So bit interval. What will be the bit interval? Bit interval is 1 microsecond. Okay, one bit lasts on transmission media is bit interval, and bit interval is what? Your time period. Bit rate is what? Just like your frequency. So frequency is what? 1 upon time period. So bit rate will be what? Bit rate will be equal to 1 upon bit interval, that is 1 microsecond, 10 power minus 6. So it comes out to be 10 to the power 6 bits per second. So it comes out to be 1 Mbps. Please let me know if anybody is having any doubt.
No, sir.
Okay, so so very simple terminology. I think I should not waste time here how I have converted and all. I have just given you idea. In previous slides also I have given you 1 microsecond, 10 to the power minus 6 seconds and so on. So bitrate will be this only. Okay, so I think that's it. So now let me jump to the next topic. Please take snapshot. So signal topic is over. So let me jump to the next slide. Done?
Okay.
Okay. So two basic terms which we should understand. One is bitrate and baud rate. Numericals have been asked on this topic, bitrate and baud rate. Bitrate, I think we already know, number of bits transmitted per second. Number of bits transmitted per second. So now our basic terminology is over. Okay, digital signal, analog signal, that is over. So signal topic is over. Now I am considering few basic terms. So bitrate is number of bits transmitted per second. What is baud rate? Baud rate is number of signal elements transmitted per second. Number of signal elements transmitted per second. Okay, so for example, if I say like this, so 1010, if I say this is 1 second, so this is one signal element. So on one signal element, 1 bit is transmitted. This is next signal element. This is next signal element, and this is next signal element. So 1010. So bit rate is 4. Bit rate is 4 bps, bits per second. Baud rate, number of signal elements, 4 baud per second. 4 baud per second. Okay, so bit rate means number of bits, baud rate means number of signal elements. Okay, so now see, this is our imagination. Like I will say, when 5 volt current is there, you will consider 1. When minus 5 volt will be there, you will say it is 0. So like this is our imagination. Do not say this is 1, this is 0. No, actually this is our imagination, and I am saying that when positive side it means 1, when potential difference is positive it is 1, when it is negative it is 0, and so on. But if I say like this, so let me draw it. So let me shift it a little bit. Yeah, so if I say this is my logic 1, this is my logic 1, this is my logic 0, so I'm considering like this. So this is Z, na, this Z is 1, this Z is 1, this is opposite Z means 0, like this I have considered. So it is actually not a Z. I am just trying to give you imagination kind of thing. Okay, so these are examples of Manchester encoding and all, but this is not in your gate syllabus now, so we can simply skip it. But I am just giving you idea because I have to explain these terms. So now how many signal elements are there? One signal element, one signal element. So two signal elements. So on two signal element, 1 bit is going. So one signal element, one signal element. Two signal element, 1 bit. One signal element, one signal element. Two signal element, 1 bit. So what is the baud rate? Baud rate is 6 baud per second. Okay, this is 1 second. Imagine this is 1 second. What is the bit rate? 3 bits per second. So here clearly you will say baud rate is twice the bit rate. Baud rate is equal to 2 multiplied by bit rate. Is it okay?
Yes, sir.
So baud rate and bit rate, now I think it is clear. So baud, you can consider them as signal elements. On how many signal elements you are transmitting one bit, that is baud rate. Okay, and bit rate means number of bits. Simple, number of bits transmitted per second. Okay, so now we will consider few numericals just to give you more clarity. Take snapshot. I will jump to the next slide.
Okay, sir.
So if question is what is the baud rate? What is baud rate if bit rate is 10 Mbps and tubes are transmitted per signal element? What will be your answer? What is the baud rate if bit rate is 10 Mbps and 2 bits are transmitted per signal element? So on one signal element, 2 bits are transmitted. So what will be your relationship? Baud rate is equal to number of bits on signal element. Sorry, bit rate. I think by common sense you will get it. I will write the formula, you will get it. Bit rate will be number of bits on one single element multiplied by bit rate. Sorry, multiplied by baud rate. Multiplied by baud rate. Are you getting it now? So baud rate means number of signal elements transmitted per second. And when I will say 2 bits are transmitted on one signal element, then obviously I will multiply them and I will get the bit rate. Any doubt here? Please let me know. Okay. So bit rate is this number of bits on signal element multiplied by baud rate. So what they are giving, baud rate if bit rate is 10 Mbps. So this is 10 Mbps. So 10 into 10 power 6 bits per second, BPS. Number of bits 2 multiplied by baud rate. So baud rate will be equal to what? 5 mega baud per second. Please take snapshot. I will jump to the next slide. Done?
Yes, sir.
Okay. So next question. Next question is find bitrate and baud rate. Find bitrate and baud rate if 1000 signal elements are transmitted per second and one signal element carries 6 bits. Very simple question. Baud rate. Very easy. It is given in the question itself. 1000 signal elements. So 1000 is the answer. 1000 baud per second. Bit rate. Bit rate is number of bits transmitted on one signal element, that is 6 multiplied by baud rate. Baud rate is 1000. So 6000 BPS or 6 kbps. Please let me know if anybody is having any doubt.
Understood, sir.
Okay, take snapshot. I will jump to the next slide.
Done, sir.
Okay. So next question can be, so 10 signal elements are transmitted. 10 signal elements are transmitted in 1 millisecond and 2 signal elements carry 1 bit. Find bitrate and baud rate. Find bitrate and baud rate. So they just want to check your units and all. So in 1 millisecond, 1 millisecond means 10 to the power minus 3 seconds, 10 signal elements are transmitted. So in 1 second, 10 upon 10 to the power minus 3, that is 10 to the power 4 signal elements will be transmitted. So 10 to the power 4 baud per second is the answer. It comes out to be 10k baud per second. That is the baud rate. So now what is the bit rate? Bit rate will be what? Bit rate is equal to number of signal n multiplied by baud rate. So what is n here? Number of bits. So bit rate will be equal to number of bits. So 2 signal element carry 1 bit. Okay, so 1 signal element carry what? 1 by 2 bits. Half bit is carried on 1 signal element. So 1 by 2 into baud rate. So what is the baud rate? 10 to the power 4. So it comes out to be 5 kbps. Please let me know if anybody is having any doubt.
Done, sir.
No, sir.
Okay. Okay, take snapshot. I will jump to the next slide.
Perfect, sir.
So one last question, very easy. I think everybody will get it, but just for sake of completion, I'm writing. Bit rate is 3 kbps. Okay, and each signal element carry. Each signal element carry 6 bits. Each signal element carry 6 bits. What is the baud rate? What is the baud rate? So bit rate is equal to n multiplied by baud rate. So bit rate is 3 into 10 to the power 3, 6 into baud rate. So 1 by 2 into 10 to the power 3 will be our answer. So it comes out to be 500 baud per second. Units are important. Take snapshot. I will jump to the next slide.
Done, sir.
Done? Okay. Yeah, so now very important part is coming. That is the you can say total delay. Okay, delay or latency. Okay, yes, or rather I should say okay, let me build the basics. Okay, if I say directly, you will might get confused that from where this topic is coming. So now I want to measure performance of the network. Performance of the network. So how you will say that my network is performing better or my network is not performing good and all. So again, performance is a subjective term. So we should have parameters to write what exactly is the performance. So 3 factors, or you can say 3. It depends on 3 factors. Okay. So what are the 3 factors? One is the bandwidth. Second is the throughput. And third is the delay. So delay is important. Numericals have been asked in GATE many times. So bandwidth, throughput, and delay. What is bandwidth? So bandwidth, I think I have told you, maximum frequency minus minimum frequency. But now they will say bandwidth of link. So what is the bandwidth of link? Link means your channel. This is your wire. This is carrying current and all. So how you will measure bandwidth of this link? So obviously you will say minimum frequency will be 0. So if you are transferring nothing, so it will be 0. And maximum, I think it depends on the material, what material you have used. So bandwidth is f max minus f min. So f min will be 0 for the channel, because 0 means you are transferring nothing. So directly and indirectly you want to find f max. So maximum frequency signal which it can carry, that is your bandwidth. Okay, so now the more is the frequency, so obviously more number of bits you can transmit it on the channel. Okay, for example, if I say like this. Okay, so in 1 second you have transmitted the signal, and you and 1 bit carry 1 signal element carry 1 bit. So 1 0 1 0 1. So 5 bits you have transmitted in 1 second. So if this channel can carry higher frequency signal, so obviously this will become more tight and so on. Na? Obviously I cannot make diagram because bandwidth is generally is Mbps and all. So how I will make 10 to the power 6 in 1 second and so on? So I cannot make that. So I'm just giving you the idea. So they will become more tight and tight. Are you getting it? Okay. So so obviously it depends on material, what material you are using and so on. So what will be the bandwidth of the link? Bandwidth means highest frequency signal which it can carry. So frequency means, so frequency is related to bit rate only. Okay, so the more will be the frequency, the more number of bits you can transmit it. So directly indirectly, bit rate will become your bandwidth. So bit rate which we are measuring till now in Mbps or kbps and all, that was the bit rate definition. So bit rate will be simply just like your bandwidth. So now you have got proper clarity that why bandwidth is measured in Mbps or kbps and all. Actual bandwidth is maximum frequency minus minimum frequency, and actual bandwidth is for your composite signals. Okay, that is maximum frequency minus minimum frequency. But now we are considering bandwidth of the link. So what is the bandwidth of the link? Bandwidth of the link means maximum frequency signal which it can carry or which link can carry. So frequency is related to bits. So that's why directly indirectly bandwidth is converted to bit rate. Like this you can link the topic. Okay. So bandwidth of link means you can say maximum frequency signal it can carry. Maximum frequency signal. And why only maximum? Minimum is 0 only, because link means what? You channel. So on channel you are transferring nothing, that will be 0. So maximum frequency signal it can carry. Maximum frequency signal it can carry, that is the bandwidth. Okay. So more frequency means more bits. More frequency means more bits. So indirectly bandwidth is just like your bit rate. Okay. Yeah. So more precisely, as you say, bandwidth of link. Bandwidth of link is nothing but your bit rate. Okay. So now I hope I have linked the topic properly. Okay. So more precisely or technically, so these are the basic things which I have told you. Technically, bandwidth means potential measure of link. That is how fast we can send data. Potential measure of link. Potential measure of link, that is how fast we can send data. How fast we can send data. That is the maximum how fast we can send data. Okay. Yeah. So that is bandwidth. Now what is throughput? For throughput, let me give you an example. Please take snapshot. I will jump to the next slide. Done? Okay. Yeah. So next is throughput. Throughput means actually how fast we can send data. Actual is throughput, and potential measure means maximum how much fast we can send data, and it is bandwidth. I will give you example. Don't worry, you will get clarity. Actually, how fast we can send data. For example, we have a channel and its bandwidth is 1 Mbps. So that means 10 to the power 6 bits per second. It is the capacity of the link. Now, but we have one sender and receiver attached to it. Sender can send data only at 200 kbps, and receiver also can receive data at 200 kbps only. So what will be the throughput? Throughput will be 200 kbps, because actually how fast we are sending, only 200 kbps. Bandwidth means maximum, that is 1 Mbps. Okay. So for example, on road 5,000 cars can be there, but it's morning time and only 500 cars are running. So 500 is the throughput, and maximum is 5,000. That is the way you can think. So throughput is 200 kbps. Throughput is 200 kbps, and bandwidth is 1 Mbps. Is it okay? Yeah. Take snapshot. I will jump to the next slide.
Done, sir.
So let me solve a simple numerical. Network bandwidth is say 10 Mbps. Bandwidth is 10 Mbps, and it can pass an average an average of 12,000 frames. 12,000 frames per minute. 12,000 frames per minute. Each frame carry 10,000 bits. So what is the throughput? They are asking what is the throughput. Throughput means actually how fast we are sending data. So this is, so in numericals you should first consider this is a garbage data which is given to you. No need of considering bandwidth and all, because throughput is not depending on this bandwidth and all. Okay, so this is the garbage data. No, you do not need this unit here. So even if they do not give bandwidth, you can find answer of this question. That's why we will call it as garbage data. And in networking, you have to remember they will simply give some garbage data just to confuse you, that so that because questions are twisted, na. So in networking, the beauty is that you simply apply the formula, get the answer. So just to confuse you, that you might get confused in GATE exam, that throughput formula was considering bandwidth or not and so on. Just to confuse you, they will give this kind of thing. Okay, but it is not required here. So now I will try to find what is the throughput here. So throughput, they will ask you find that in BPS. They will say like this. In BPS we want to find. Okay, so it can pass on an average 12,000 frames per minute. So in 60 seconds, how many frames are transmitted? 12,000. So in 1 second, 12,000 divided by 60, so it comes out to be 200. So 200 frames are transmitted per minute per second, and each frame carry 10,000 bits. So 200 into 10,000, that is 10 to the power 4 bits per second. So it will be 2 into 10 to the power 6 bits per second. So if they say in Mbps, you will say 2 Mbps is the throughput. Okay, so bandwidth was 10 Mbps, but network is capable of transmitting only 12,000 frames per minute. Each frame carry 10,000 bits. So what will be the throughput? Throughput will be 2 Mbps only. Okay. Yes, any doubt? Please let me know.
Understood, sir.
Take snapshot. I will jump to the next slide. Done?
Yes, sir.
Okay. So now very beautiful term or very important term is coming. So we have considered two factors, bandwidth and throughput. Now delay. On delay, numerical have been asked in GATE. Yeah, so delay or latency. So let me consider that. So delay means, see this, we have a sender and we have some intermediate nodes, we call them as router and all, and we have a receiver. So total delay means how long it will take to send entire message from sender to receiver. That means the moment the first bit leaves the sender, for example, this is your message, this big is your message. So the moment the first bit leaves the sender, you will start your clock, and the moment the last bit is received by receiver. So when last bit received and receiver is over, then you will stop your watch and say, okay, this is the total delay. Are you getting it? Total delay means the moment the first bit leaves the sender and the last bit receives at receiver. So total delay between that is known as, or you can say time taken for transferring this entire data, that is known as delay. Are you getting it? Okay, so if you yeah, so please write the definition. I'm dictating just to save the time. How long it take for entire message? How long it take for entire message to completely arrive at destination? How long it take for entire message to completely arrive at destination? To completely arrive at destination from the time the first bit is sent out from source, from the time the first bit is sent out from source and last bit arrives at receiver. From the time the first bit is sent out from source and last bit is arrived at receiver. Okay, so you have to consider entire time from the time the first bit is sent out from source and last bit arrives at receiver. Okay, that is the basic meaning of total delay.
Yes, sir.
Okay, so now we will consider on what it is dependent, or you can say types of delay. Types of delay. So the first is known as propagation delay or propagation time. Propagation time or propagation delay, one and the same thing, time or delay. Next is transmission time. Transmission time or delay. Next is queuing time. Queuing time, queue, data structure you have studied, na? So queuing, so queue time. And the last is processing time. Processing time. So these are the total 4 types of delay. So one by one we will consider them. Okay, so what are these? Propagation time or delay, next is transmission time or delay, then queuing time, and then processing time. So one by one we will study. Take snapshot, I will jump to the next slide and I will give you the idea.
Done, sir.
Okay, so first is propagation time. So what is propagation time? Propagation time is time required for a single bit to travel from sender to receiver. Okay, so from sender to receiver, if you send only one bit, so how long one bit will take to reach from sender to receiver? That is propagation time. Or you can, in short, I will say 1 bit delay. 1 bit delay is propagation time. Okay, propagation time is time required for a bit. Time required for a bit to travel from sender to receiver. Travel from sender to receiver, S to R. Okay, that is propagation time. Okay, and for considering propagation time, we will ignore all the routers and all between them. Okay, so directly and indirectly I want to say, if sender and receiver, if nothing is there between them, sender and receiver are connected via single line or via dedicated link, then 1 bit delay is your propagation time. Okay, so let me write it. If S and R are connected via dedicated link means nothing is there between them. If sender and receiver are connected by dedicated link, then 1 bit delay is TP. TP means propagation time. Okay, so time required for a bit, single bit, for a bit to travel from sender to receiver. Any doubt here? So if sender and receiver are connected by a dedicated link, then 1 bit delay is propagation time. Okay, so for numericals, what you will say, from here to here 1 bit time, that is TP. From here to here TP. From here to here TP. From here to here TP, because this is a dedicated link. So first this is sender and this is the receiver. Na? It will receive the frame. Now this is sender, this is receiver. So it will receive the frame, sender, receiver, like this. Okay, so what is propagation time? Time required for a bit to travel from sender to receiver. So if nothing is there, between sender and receiver, so you will say 1 bit delay is nothing but your TP. Any doubt here? Please let me know.
Understood, sir.
Okay, so according to you, what will be the formula of propagation time? Very, very simple. Time is what? Distance upon speed. So TP will be equal to, let me write it properly. Time is equal to distance upon speed. Na? So TP will be equal to what? Distance they will give you in kilometers and all, and speed you will take it as speed of light. So whatever they will give, you can take it. Okay, so let me solve a small numerical just for the sake of completion. Take snapshot, I will jump to the next slide.
Copied, sir.
So question is distance between sender and receiver. Distance between sender and receiver is 12,000 kilometers. 12,000 kilometers. Speed of light is 2.4 into 10 to the power 8 meter per second. Now this is given to you, so you have to take this only. Okay, C is given to you, and they are saying find the propagation time or TP. So TP is distance upon speed. So they just want to check you know units or not. Or 12,000 kilometer na, and this is meter. So kilometer should be converted into meters. So I will directly say 12 to 10 to the power. Any doubt here?
Yes, sir.
Divided by 2.4 into 10 to the power 8 meter per second. So it will be 0.2. So it will be 1 by what? 1 by 20 seconds. No? 1 by 20 seconds. So it weighs nothing but 50 millisecond. Any doubt here? 1
Yes,
by
sir.
20 second is so 50 millisecond is my answer. So see the speed of light, na, see the power. In for 12,000 kilometers, it is just taking 50 millisecond time. Okay, so that will be your TP or propagation time. That's why computer networks is very successful. If speed of light was very less, then obviously computer networks are not successful. Na? It will take hours and hours to transfer data from your computer to any computer in US or any computer in Canada and so on. So it will take hours and hours, but now it only take millisecond time. Okay, just because speed of light is very, very high. Okay, so take the snapshot. I will jump to the next slide. Done.
Yes, sir.
Okay, so next is transmission time. Transmission time. So what is transmission time? See, this is your sender. So this is the message which sender wants to send. So how long sender will take to put this entire message on the transmission media? It hardly matters it has reached the receiver or not. I am just saying how long sender will need, how long sender will take, or how much time sender will take to put this entire message bit by bit on this transmission media. That is the transmission time. Okay, are you getting it? So how long the sender will take to put this entire message on the transmission media? So so please write the definition, you will get more clarity. What is transmission time? Transmission time is the time needed by sender. Transmission time is the time needed by sender to place the packet on transmission media. Transmission time is the time needed by sender to place the packet on transmission media. Place the packet on transmission media. That is transmission time. So how you will find transmission time? Transmission time is represented by TT. TT is nothing but your message size divided by bandwidth. Message size upon bandwidth. So how big is the message and what is the bandwidth? Okay, so for example, see this, I can say like this. If you want more clarity that why transmission time is message size upon bandwidth, I will say like this. So if my bandwidth is 1 Mbps, 1 Mbps. So what do you mean by 1 Mbps bandwidth? So that means sender will put 1 bit on transmission media in microsecond. In 1 microsecond. So in each microsecond, sender will keep on putting the bits on the transmission media. Are you getting it? So because bandwidth is 1 Mbps, so sender will keep on putting the bits one by one in each microsecond. So in each microsecond, sender will keep on putting the bits on the media. Okay, so now if message size is say 1 kilobytes or 1 kilobit. Okay, and let me clear one thing. 1 KB means kilobit and 1 KB, capital B means byte. Okay, so you have to consider this. So small b means bits. Let me write it. Small b means bits. Capital B means bytes. These are the few terminology which you should remember for the GATE exam. Okay, B means bit, capital B means bytes. So 1 kilobyte means 8 KB, na? 8 kilobits. These are basic thing. I think you already know these things, na? Any doubt here?
No, sir.
Okay, yes, good. So message size is 1 kilobit. So in 1 microsecond, 1 bit is transmitted on transmission media by sender. So for 1000 bit, how much time it will take? It will take 1 millisecond. So 1 millisecond is your transmission time. And how I have calculated 1 millisecond? That is message size upon bandwidth. So 1000 upon 10 to the power 6, that is 1 millisecond. Please let me know if anybody is facing any difficulty here. This analysis is okay to everyone?
Yes, sir.
Yes.
Okay, so that's it. So this is the proof that why transmission time is message size upon bandwidth. So bandwidth means how long, or you can say how fast sender can send bits on the transmission media, or how fast sender can put the bits on transmission media. That is the bandwidth. 1 Mbps means in 1 microsecond sender will keep on putting the bits on the transmission media one by one. Sender will keep on putting the bits on the transmission media, and how long it will take to put one bit on transmission media, that is given by your bandwidth. Okay, so message size upon bandwidth, that will be the transmission time. So transmission time means time needed by sender to place one packet on transmission media, or I think you have got it. Okay, so now let me solve a small numerical. Take snapshot. I will jump to the next slide.
Copy, sir.
So just for sake of completion, I am giving you a numerical. So question is packet size or message size, whatever they want they can give. Packet size is 2.5 KB. Okay, bandwidth given is 1 Mbps. What is the transmission time? So now please try to focus here carefully. Capital B is given, that means bytes. So 2.5 into 10 power 3 into 8. Why 8? Because I have to convert it into bits, because here this is bits. So it's up to you. You convert it into this converted into byte, or this converted into bit. So bit conversion is easy. Multiply by 8, you will get the answer. So divided by 1 Mbps, that is 10 to the power 6. So finally, what will be our answer? This will become 10 to the power 3. Okay, so 2.5 into 8. So 200 upon 10 to the power 3. Oh, sorry, 20, na? 20.0, 20.0, na? 2.5 into 8, 200. So point will be there. So it will be 20 millisecond. So simple. 10 to the power 3 seconds it is coming, na?
Yes, sir.
Units is very, very important. So 20 millisecond is my answer. Okay. So take snapshot. I will jump to the next slide.
Done. Copy.
Okay. So now a very important point is coming. So please try to focus here. So I'm saying that we have a sender and receiver. So they are connected via dedicated link. Okay. And speed of the wire, or you can say speed of signal, is given to us as 2.4 into 10 to the power 8 meter per second. Bandwidth given is 1 Mbps, and message size is 2.5 KB. Okay, so and they want us to find the total delay. What is the total delay to transmit the data? Okay, so now since they are connected by a dedicated wire, so I will say there is no queuing time and processing time. I have not given you information about what is queuing time and processing time, so you simply just ignore them. Nothing is there, queuing time, processing time, because they are connected by a wire, na? Single wire. So we do not need all these things. Okay, yeah, so forget about it, just forget about it, try to concentrate here. So what is the total delay? So I want to find the total time. What is the total delay means what? Definition, according to definition. See this, I have given you the definition. So what was the total delay? Yeah, I think I have not written, but you have written in your notes. So one bit, from the moment first bit is sent out from the source and the last bit arrived at receiver. So what is the total time? Total time from the first bit is sent out and last bit is received by receiver. That is the total delay. So please tell me what will be the total delay in this scenario. So what I will say, so the first bit sender will put in 1 microsecond. First bit it will put in 1 microsecond. Second bit also in 1 microsecond. So 1 microsecond, 1 bit will put on the media, and so totally all the bits will be on the transmission media. In how much time? That will give you by transmission time. Transmission time is message size upon bandwidth, and I have proved you in the previous slide only. Message size, what is the message size? 2.5 KB. So okay, so I have taken the same units. It will be 20 millisecond. So I will say 20 millisecond. So in 20 millisecond, all the bits sender has sent on the media. Now question arises, in 20 millisecond, receiver has received all the bits. No, sender has just put all the bits on the transmission media. Are you getting it? In 20 millisecond, sender has just put all the bits on the transmission media. That's it. Okay, now they have reached or not, that depends on the propagation time. So what was the propagation time? Same numerical I am using now, just to save the time. So speed is 2.4. Okay, distance I have not given, so distance is very same, 12,000 kilometers. So propagation time was what? 50 millisecond was there. So I will say, what I will say, in 50 millisecond, the very first bit which sender has sent, it will reach at the receiver. So very first bit, it will reach receiver at 50 millisecond, and then subsequent bits will keep on coming one by one in 1 microsecond each. So they will take 50 millisecond more. So total delay will be what? Propagation time plus transmission time. Propagation time is 50, transmission time is 20. It will be 70 millisecond. Please let me know if anybody is having any doubt.
Understood, sir.
No, sir.
Yeah. Yeah, please, somebody was speaking. Any doubt?
No, sir.
Okay, good. So it has put all the bits in 20 millisecond, but first bit received at receiver at 50. So then subsequent bits will keep on coming in how much time? 20. So 50 plus 20, that is 70. Okay, so now some students might get confused here. So sir, each and every bit, say if propagation time is 50 millisecond, so each and every bit will need 50 millisecond to reach at receiver. So how you are saying 50 plus 20, 70? So it's just like that. I will give you an analogy. I will say you are traveling from Delhi to Bombay, and the train is taking 20 hours to reach from Delhi to Bombay. Engine also need 20 hours. Your first bogie also need 20 hours. Second bogie also need 20 hours. Third bogie also need 20 hours. So you will add all 20 hours? No, because they are coming just one after another. So only engine is needed. Only engine is taking 20 hours. Rest bogies are keep on coming after that only. So that is the scenario here. So only first bit will need the time. That is the propagation time. But rest bit will keep on coming one after another. So do not say, no doubt, each and every bit need 50 millisecond to reach from sender to receiver. Each and every bit need 50 millisecond. But I am not counting that because we are doing everything parallelly. Like parallelly engine is coming, first bogie, second bogie, third bogie, all are coming parallelly. So you just consider each and every passenger traveling in the train. Each and every passenger is taking 20 hours to reach from Delhi to Bombay. Now, if 1000 passengers are there in the train, should I say that 20 hours into 1000 is the total time? No. I will say only 20 hours because all are traveling parallelly. So same is the scenario here. So no doubt individually each and every bit needs 50 millisecond. But if you consider this, see this, one bit, each and every bit is taking 50 millisecond only, but they are traveling parallelly on this media. Okay, so collectively I will say 50 for the first bit, and for rest bits they are coming one after another. So 20 for that, because 20 millisecond sender has taken to put that the entire message on the media. Now I think it's crystal clear now.
Yes, sir.
Okay, so now please take snapshot. I will jump to the next slide.
Copied, sir.
Okay, so total delay we have found out to be TP plus TT if they are connected via a dedicated link. But it is not the case now. See, it was next to impossible case. 12,000 kilometer I have stretched a wire. It is not possible. So now I will give you practical things. So for one sender, then we will have some nodes in between, and then we will have a receiver. Okay, so now sender will send your packet to this node or router. So now this router is having multiple you can say ports now. So there might be multiple senders which are sending data to this router. So multiple packets are coming to this router, and obviously router is not so much fast. It cannot process the data. For example, take your example. I am keep on speaking. You might not be able to understand all the things. So what you have kept? You have kept a notebook. In that notebook, you are keep on writing the notes. because if you not write the nodes, you will be overwhelmed. So same is the scenario with the router. So router cannot process the data at the same time, so he will keep a queue. So all the packets, whatever packet is coming, they will kept in queue one by one. One by one, they will be kept in the queue. And according to its convenience, according to the router convenience, he will keep on picking one packet, and it will keep on processing it, and then it will forward to the port from the respective port. Okay, so router maintains a queue, and this it is not a single queue. On each port, it is having a queue. Okay, so if router is having 5 ports, so with on each port, it is having a very big queue of packets. Okay, which are lined up to be sent and received and so on. Okay, and in fact there are two different queue: sending queue and receiving queue. Sending queue means a router has processed the data, but this line is very slow, na? Okay, this line is very slow, so router will maintain let me write it. Okay, actually I will tell you all these things when we will jump to the topic of nodes, or you can say networking devices, like I have told you: bridge, switch, router, gateways, and so on. But let me give you the idea here itself. So this is a router, so it will maintain this is a port. Okay, this is a line. So on this line, it will maintain 2 queues. One is incoming queue, like packets which are coming from this wire, and one is the outgoing queue, like router has processed the packet and it will put them in the queue, and accordingly they will be put on the wire. Because if bandwidth is less, so obviously all the packets cannot be sent, na? Router speed is very high. So incoming queue and outgoing queue, both are there for each port of the router. Okay, so forget about these details. I have just given you idea so that you get more clarity. Yeah, so the basic thing is that when packets arrive at the router cannot process them immediately. It will put packets in the queue, and one it will pick the packet, process it, and send it from the respective queue. Sorry, from the respective port. Okay, so what is the time spent by one packet in this queue? That is known as queuing time. And it entirely depends on the traffic in the network. More is the traffic, more big will be the queue. Okay, and if the queue becomes full, or you can say this buffer become full, then packet will be discarded, and the moment packet is discarded, router will send ICMP error message to the sender that your packet has been discarded. So please slow down. I cannot process packets on such faster rate. Like this, they will communicate and so on. Okay, so queuing time is time, you can say time spent by packet in queue of the node. Okay, yeah, please write the definition. What is the queuing time? Time spent by packet in the queue, time spent by packet in the queue or buffer, time spent by packet in queue or buffer of each intermediate node. Time spent by packet in queue or buffer of each intermediate node. That is known as queuing time. Time spent by packet in queue or buffer of each intermediate node. Okay, that is queuing time. Yes, any doubt here?
No, sir.
Okay, so this is queuing time. And now next is processing time. So I think you have already got it. What is the processing time? So router has now picked the packet, and now it will process it. Process it means it from the header it will check IP address of the receiver, that what is the receiver and all, and then it will check its routing table. So from that means from which port it has to forward the packet. So accordingly it will put the packet in the outgoing queue of the respective port. Okay, so the time taken by router to do all the things, that is the processing time. So roughly you should say time taken by intermediate node. Forget about routers also. Time taken by intermediate node to process the packet, that is known as processing time. Simple. So processing time, take the definition: time needed by each intermediate node. Time needed by each intermediate node, or even end device also. Receiver after receiving the packet, immediately it cannot forward now. So it has to delete the headers, and then it will forward to the upper layer and so on. So it also need some time to process the packet. So that is the basic scenario. So time needed by each intermediate node or end device. Time needed by each intermediate node or end device to process the packet. Time needed by each intermediate node or end device to process the packet is known as processing time. Okay, time needed by each intermediate node or end device to process the packet is known as processing time. Okay, so now I think you have got it. Now I think what will be the total delay? Total delay will be propagation time plus transmission time plus processing time, rather first queuing time. You should write first queuing time and then processing time. In serial order I have written so that you get more clarity. So total delay is propagation time plus transmission time plus queuing time plus processing time. Is it okay?
Yes, sir.
Okay, so now take snapshot. Yeah. Okay, so should I jump to the next slide now?
Sir.
Okay, so now I will give you another a small numerical just to give you more clarity. Okay, so what is the numerical? Let me show you that. I will write the numerical roughly, okay, just to save the time. I will not write the entire statements. So what they are saying, question is, sender wants to send packet of 10 power 4 bytes. So packet size is given as 10 to the power 4 bytes. Okay, and sender and receiver are connected via router. S and R are connected via router. Via a router. That means only one router is there between them. Okay, TP, that means propagation time. TP and bandwidth. So let me write it properly. TP is 1 millisecond. Bandwidth is 10 to the power 6 bps. And queuing time is given as 5 millisecond. Processing time is given as 10 millisecond. And they want us to find total delay. Okay, yeah. So what will be our answer? So total delay is what? You simply add it. It is very simple. So propagation time is 1 millisecond. It is given to us. What is total delay? Let me write the formula first. Total delay is propagation time, transmission time, queuing time, processing time. Propagation time is 1 millisecond. Transmission time, message size upon bandwidth. Message size is what? 10 to the power 4 bytes. So 8 into 10 to the power 4 bytes, na? Because it will become bits. Bandwidth is bits per second. It is bytes. So convert byte into bits. So divided by 10 to the power 6. So it comes out to be 80 millisecond. Any doubt here? How 80 has been come? Any doubt?
No, sir.
No, sir.
Okay, very good. So 80, then queuing time. 5 millisecond is the queuing time. Processing time is 10. So what will be your answer? 96 millisecond is the answer. That's it. So it's very simple numerical. Okay, now they can say, so sender, and this is very important. Now sender and receiver are connected via a router. That means sender, router and receiver. So only one router was there. So you have considered these things. Okay, yeah. And one more thing. Yeah, actually, see this. So TP is given as 1 millisecond now. So from here to, yeah, we have done a small mistake. We should do it properly. So this is my suggestion to you. In gate, if question comes, do not try to do like this, which I have done. I have done a silly mistake. I will tell you why. What is the mistake? So sender and receiver are connected via a router. Na? So you just make this diagram first. So after making diagram, you will say from here to here, what will be the time? From here to here, 1 TP plus 1 TT. So in 81, from sender to this router, packet will be received. Now queuing time and processing time will be done. And then from here to here, again, one is the TP and 81 is the TT. Sorry, 1 is the TP and 80 is the TT. So 81 again. So plus 81 you have to do. Are you getting it?
Answer.
So I will say plus TP plus TT. I have written it, showing you by red so that you get more clarity. So plus TP is 1 and TT is 80. So now you will find it. What will be your answer? 80, 80, 160, 170, 172 millisecond is the answer. Is it okay?
Yes, sir.
So you have to remember this kind of thing. They can say like this, okay? Yeah. And if they say via two routers, then obviously you will consider queuing time and processing time 2 times.
Sir, 177, right?
Okay, so I have done a mistake. 177. Yes, 177. Yeah. Please continue. What you were saying? Multiplied by 2.
Yeah, sir. Multiplied by 3. That way we can just enhance, no?
So okay. So let me show you what exactly will be done. So if there are two routers in between, so what you will say, total delay. Let me write it properly and let me make a formula so that you get more clarity. So I will say there are three are there na. So I will say 3 into TP
Yes, sir.
plus 3 into TT plus 2 into queuing time plus 2 into processing time.
Okay.
Okay. So now I think it is not multiplied by 2, it is somewhat different thing. Okay, so general formula. So if n nodes are there, so what will be your answer? N plus 1 into TP plus n plus 1 into TT plus n into QT plus n into PT. Okay.
Yes, sir. Yes, sir.
And you have to okay, so if they are saying total processing time, then obviously you will no need to consider this n and this n. If they say total processing time, that means they have given they have summed up all the processing time of all the routers. So obviously you will not consider this n now. Okay, and if they say total queuing time is given to us, then you will say okay, I will not consider this n.
Okay.
I think you can think that from the numerical point of view. That is very easy. Okay, so generalized thing I have given you. So now take the snapshot of this, then I will jump to the next slide and I will show you a gate question. Very, very beautiful question I've been asking it. So that is the beauty of gate exam. Na? So they will, I have just given you idea of one packet. Na? So they will extend this. Okay, so they will extend it means 10 to 20% more they will ask. Let me show you the question. You will get more clarity. Take the snapshot. Done?
Yes, sir.
Okay, so now let me show you the question, gate question, what they have asked. See this. So what they are saying, yeah, so two hosts are connected via a packet switch with 10 to the power 7 bits per second links. Okay, so each link has propagation delay of 20 microseconds. So they just twist it. Packet switch means you can think of it as a node. So this is a sender. Okay, so this is a node and this is the receiver. This is the scenario. Okay, and what they are saying, each link has propagation delay of 20 microsecond. So yeah, I want to clear this thing also. So now say this. So if they say total propagation time, so you will ignore this n plus 1. If they say total actually that will create confusion. Okay, if I say if they say, okay, just a second, kya hua? Yeah, so and if they say total propagation time, that will be a bit difficult kind of thing. Okay, that will create confusion. So generally you will take like this only. Okay, so n plus 1 into TP, n plus 1 into TT, like this. Okay, so propagation time from here to here, one propagation time, from here to here, one propagation time, from here to here, one propagation time. So they will say precisely, they will say propagation time of each link, like this. So this is the wording I want to focus here. Each link, see this, each link has propagation delay of 20 microseconds. So from here to here 20, from here to here 20. Is it okay? Yeah. Next, the switch begins forwarding the packet 35 microseconds after it received the same. So now can you guess what they are saying? The switch begins forwarding the packet 35 microseconds after it has received the same. That means after receiving, it will take 35 microseconds. So that means what? Queuing time plus processing time. Total they have given you 35 microseconds. Any doubt here?
No, sir. Understood, sir.
No, sir.
Okay. So you just have to understand this terminology. That's it. So now I have just given you the concepts. So now I am giving you the idea how to apply the concepts. Okay. So 35 microseconds. Okay. Then if 10,000 bits of data are to be transmitted between the two hosts using a packet size of 5,000 bits, the time elapsed between the transmission of the first bit of data and reception of the last bit of the data in microseconds. Are you getting it? Time elapsed between transmission time of the first bit and reception of the last bit by the data. That means total delay. Total delay they want to ask. That is the exact definition they have used. So they will just twist the question. Okay, so they will not say total delay. So if you know the definition, you will get the idea. Okay, they are asking total delay. If you do not know the definition, then you will keep on struggling, but they are asking and so on. Okay, so they will just try to twist the things. That's it. Okay, so what they are saying, two hosts are connected via packet switch network, 10 to the power 7. So let me write the data. Bandwidth is 10 to the power 7 bps. TP is 20 microseconds. Okay, and the queuing time plus processing time. Queuing time plus processing time, that is given as 35 microseconds. Okay, data is if 1000 bits of data are to be transmitted. So now see the beauty. I have just shown you for one packet only. For one packet, this was our you can say formula, because if I want to transfer only this thing, only one byte, only one packet. But now they are saying what? 10,000 bits of data are to be transmitted between two hosts, packet size of 5,000 bits. That means two packets will be transmitted.
Yes.
Are you getting it? So two packets. This is very beautiful question. Two packets. So 2015 question is this. Okay, 2015. So two packets, each of size 5,000. Two packets, each of size 5,000 bits. So they are not saying bytes, they are saying bits, and it is also bits per second. So no doubt, no problem, no conversion and all. Okay. Now the time elapsed, they are saying. Okay. So what should be done now? So two packets. So sender has to send two packets, each of size 5,000 bits from here to here. So what should be done first? So sender will send first bit. So what will be the time taken to send first bit from here to here? 20 microseconds. So 20 microseconds for first bit. Then each and every bit. See, actually you might say small minor glitch or minor calculation mistake. You will say, sir, first bit is taking 20 microseconds and rest other bits are coming one after another. So total there were 10,000 bits. So one bit already gone. So 4 times 9, 9,999 bits are remaining, and each bit will need what? 0.1 microsecond each. So answer should be 9999 into 0.1 microsecond plus 20. Are you getting it? I'm going into very much detail so that each and every point should be crystal clear in your mind. Now please tell me, where is the mistake? Can anybody tell me? Have you got my question?
It says there are two packets to be transmitted. So
it will be transmitted one after another, na? So do not think that one packet will be transmitted, then second will be transmitted. No, they will be transmitted one at the same time. If they want that thing, they will clearly mention that after first packet has been received by receiver, then second packet will be transmitted, and that is really very trivial question. They will not ask such question. Rather, if they ask, it's your good day. You will simply solve it. I will tell that thing also. Don't worry that how you will solve that and so on. And okay, I have given you this formula, na? For one packet, this is the case. Multiplied by 2, you will get the answer. Very simple. Okay, so they are not saying like that. If they want to say like that, they will properly mention that after first packet has been received by receiver, then second packet will be sent. So for that scenario, for one packet, time is this, multiplied by 2, you will get the answer. Okay. Yeah, so first confusion, I think I have over. First confusion was one by one. It is not one by one, parallelly. So sender will send all the bytes, all the bits one after another. So it's our, you can say, way of understanding that 2 packets of 5,000 each. So now why, so you may argue, sir, why after all, why you are saying like that? Just because of this is the biggest problem. The switch began forwarding the packet 35 microsecond after it has received the same. So for one packet, it needs 35 microsecond to process it. Okay, that's why 2 packets is meaningful here. Otherwise, you will say only 1 packet. So you will say, sir, it hardly matters either 2 packet, 3 packet, or 10 packet. One and the same thing. Sender will keep on sending the data. But no, this router will take time. Okay, that's why 2 packet, 3 packet, 4 packet will be meaningful here, because for each packet 35 microsecond time. Please let me know if anybody is having any doubt.
Yes, sir.
Okay, so now I want to say that 10,000 bits sender will send at once to the receiver, to this router R1. Okay, so first bit, now my question is, first bit will need 20 microsecond, because wo engine wali kahani of 20 first bit will need 20 microsecond, and rest of the bits, how many bits are remaining? 9,999 bits are remaining. Each will need 0.1 microsecond. Why 0.1 microsecond? 10 to the power 7 bits per second is the bandwidth, na? So one bit need 10 to the power minus 7. 10 to the power minus 7 is 0.1 microsecond. So 4 times 9 into 0.1 microsecond. So where is the gap? So gap is very simple. You will say, sir, you are transmitting first bit. So obviously first bit has also needed 1 microsecond. Na? So do not say, sir, rest of the bits will need 1 microsecond. Sorry, 0.1 microsecond. Each bit need 0.1 microsecond. So first bit which you have sent, that also need 0.1 microsecond. So obviously I will add properly. So I will say 10,000. So 10,000 into 0.1. So 10,000 into 0.1 plus 20. So 10,000 into 0.1, that will be 1,000 microsecond. 1,000 microsecond is nothing but 1 millisecond. So 20 plus 1 millisecond. So in 21 millisecond, what you have transmitted in 21 millisecond, sender has sent entire data to this R1. Please let me know if anybody is having any doubt.
No, sir. Clear, sir.
Okay, so in 21 millisecond, entire data from sender to router 1 has been transmitted. Now see the important fact. Actually, it will confuse us. In place of converting into millisecond, please take it as microsecond. It hardly matters. So I will say 1020 microseconds. I think it is same, na? Any doubt here?
No, sir.
Okay, so 1020 microsecond. In 1020 microseconds, sender has sent entire data to router 1. Okay, so yeah, actually I have done a very small mistake. 20 microsecond and it was 1 millisecond. So how you are adding them? 20 microsecond plus 1 millisecond. So 1 millisecond should be converted to microsecond. 1000 microsecond plus 20. So you will get 1020 microseconds. Any doubt?
Yes, no, sir. Yes, sir.
Okay, so in 1020 microseconds from sender to router R1, entire data has been transmitted. So now please try to focus here. One packet has reached router R1 in how much time? You will say 520 microseconds. Why? Because in 500 microseconds, see 5000 bits, na? So 0.1 microsecond for 1 bit, so 5000 bits, 500 microsecond. So in 500 microsecond, 500 plus 20, na? So 520 microsecond, first packet has reached R1. So now R1 will not sit idle. It will keep on processing. So it will process for 35 microsecond, and then it will forward to this receiver. Are you getting it? Everything is done parallelly. So try to analyze the thing. The more you analyze, the more you get. So 1020 microsecond, entire data reach R1. So now in 520 microsecond, first packet reach R1. So obviously second packet reach R1, second packet reach R1 in 500 microsecond. Are you getting it? So propagation time I have considered only once. I am not considering twice because each and every bit is coming parallelly. So first bit has taken 20 microseconds, and then rest each and every bit is taking 0.1 microsecond, one after another. So this is the beauty. So first packet has been reached in 520 microsecond, and the next packet has reached in 500 microsecond to R1. Please let me know if anybody is having any doubt.
No, sir.
Okay, so you can consider like this also. In 1020 microsecond, entire data reached. So first packet reached in 520. Why 520 for first packet? Because for first bit 20 microsecond, and for rest 500 microsecond. So 520 microsecond first packet. So 1020 minus 520, that will be 500 microsecond. So second packet reach R1 in 500, next 500 microsecond. Okay, so now start the clock. Now see carefully. So now please start your clock. Now what I will say? I will simply say after 520 microsecond is over, this R1 has started processing the data for 35 microseconds. So 520 plus 35, what will be your answer? 555, 555, no? So at 555, R1 has started transmitting the data bit by bit towards this receiver. Are you getting it?
Yes, sir.
So at 520, R1 has received the entire packet. So after receiving, it will not keep idle, because I have said the switch began forwarding the packet 35 microsecond after it received the same. So it has received in 520. So now why it will sit idle? It will keep on transferring the data. So it has started at 555 for transmitting the data. So at 555 it has started, and after that 20 microsecond for first bit, and then for rest of the bits 500. So what is the time? 1075 microseconds. So in 1075 microseconds, first packet received by receiver R. Okay, yeah. And now for the next packet, second packet, next 500 microseconds were there, na? Yeah. So after receiving, R1 will receive the next packet in the next 500 microsecond, and then will forward the same. Okay. So now what will be our answer? So what they are saying, time elapsed between the switch began forwarding 35 microsecond after it has received. Yeah. So second packet has been received after 1020, na? So after 1020 plus 35, so 1055. So after 1055 microsecond, it will start forwarding the next packet.
Yes, sir.
So at 1020, it has received the entire message, or you can say it has received the second packet. R1 has received the second packet. So it will start forwarding at 55. Okay. So 1055 now plus how much time it will take. So see this. First packet received by receiver at 1075. Now, so now my question is that on this route, is this route idle or something is there on this route? So my question is that 1055. So till 1055, this R1 was sending the packet, or it has left the packets, or it has stopped. So I will say like this, say this, 555, it has started the first packet, and then first packet received, see this, first packet received, okay, and okay, what I have done, what was this 555?
That was the first packet received with the first router, sir.
Yeah. So first router started sending, na? First router started sending.
520 plus 35.
Yeah. So okay, yeah. And now I have got it. So let me show you. So I will say first router. Let me write it here with a different color. So first or R1. R1 started sending first packet at 555, and it has transmitted for next 500 microseconds. So 1055. So till 1055, it has transmitted first packet. It has finished. It has finished transmitted first packet. Please let me know if anybody is having any doubt here. So R1 started sending first packet at 555. I think you already remember how this 555 came into the picture, because at 0 time sender has started. So 20 for the first bit, and then 500 for the next subsequent bits. So 520, R1 has received the first packet. It will not sit idle. It will process the packet for 35. So 520 plus 35, it is 555. So at 555, R1 is ready to transmit the data. So R1 has started sending first packet at 555, and it has transmitted for the next 500 microseconds. That is till 1055. It has finished the transmission of the first packet. Are you getting it? It has finished the transmission of first packet at 1055. Now see the beauty. At R1, second packet has been received by R1 at 1020. Are you getting it now? Because I have told you at 1020 microsecond entire data reach R1. So second packet has been received by R1 at 1020. So now after receiving the packet, it will start processing. So 1020 plus 35, that is 1055. So at 1055, it will start forwarding the second packet. It will start forwarding second packet at 1055. Are you getting it? It has finished the transmission of first packet at 1055, and it has started forwarding the second packet at 1055. Same time. So that means what? There is a queue kind of thing. That means what? Bits are going line by line. So now I will say, now do not consider this 20 again. Propagation time will not be considered for the second packet. Like at the sender side, I have told you first packet need 520, but second packet need only 500. Why 500? Because continuously sender is sending that data to this router. And now I have proved you properly that router is also sending continuously. If there was a little bit gap also, now for example, R1 has started finished at say 1000, but R1 has finished sending first packet at 1000, and it has started transmitting second packet at 1055. So if there was a gap of 55, then obviously you will consider propagation time again, because now channel will be idle. Are you getting it? So just like that, train has started. So if train is having 20 bogies, so all will reach from Delhi to Bombay in you can say 20 hours. But if you want to say after this train has departed, 20 bogie train has departed, and you decided no, I want to send 20 bogies more, then you have to apply another engine and you have to make another train and you have to transmit that. So obviously it will take some delay also. Okay, but if the train has not yet departed, 20 bogie train has not yet departed, you want to you decided that I want to send 20 bogie more, so simply you will attach 20 bogies to your given train, and this train of 40 bogies will be gone, and obviously it will take 20 hours only. There is no separate delay kind of thing. That is the best example to explain these things. Are you getting it? So at 1055 it has stopped, or you can say it has finished transmission of the first packet, and at 1055 only it has started transmission of the second packet. So where is the need of propagation time? No need. So now after next 500 you can say microseconds, second packet will be transmitted. So at 1055 it will start forwarding the second packet. So and second packet transmission time is 500. So you will need next 500 and entire data will be transmitted. So plus 500, and what will be our answer? 1555. This is our answer. Any doubt here?
Understood, sir.
So yeah,
Each link has propagation delay of 20 seconds. So second link will also have another 20 microsecond delay. So total answer will be 1575.
okay, yeah. So I have not considered that. Let me check that out. 555 was there. Yeah. I have, yes. Sorry for that. I have forgot. So 1575 will be our answer. One time I have to consider. No, I have not considered even one time also. One time I have to consider. So 1575 is the answer. Yes, it's good. So please let me know if anybody is having any doubt here. So let me say like this. Okay. So yeah. So actually I have added here. So I should add here. So 555 plus 20 plus 500. In this time, first packet I have told you, 1075 na 1075 microsecond. First packet is received by receiver. So next packet will come in next 500. So what will be our answer? Do not say here. You will say here. So plus 500, because TP will be not considered next time. So answer will be 1575 microsecond. Is it okay now?
Yes, sir.
Okay, so if anybody want me to repeat this, I will repeat it in, or I will give you summary in 5 minutes. If anybody want it, I can give you. Otherwise, I will jump to the next slide and start our next topic. Please let me know. Anybody want summary?
Yeah.
Yes, sir.
Okay, so let me give you the summary. Okay, yeah. So sender has started sending the data, and they have not said anywhere that sender will stop sending first packet, and after receiving acknowledgement and so on, it will send the next packet and so on. It has not said anything here. So what you will say? You will say 2 packets sender has to send. So it will send them one after another. So first bit will need 20, and rest each and every bit need 0.1 microsecond. So and 10,000 bytes is 10,000 bit is there. So 1,000 microsecond. In 1,000 microsecond, sender will put entire data on this link, and 20 microsecond for the TP. So in 1020 microsecond, entire data reach R1. R1 has received entire data in 1020 microsecond. But what was the scenario here? 2 packets were there. So I will say in 520 microsecond, first packet reach R1. Why in 520? First bit from receiver, it will take 20. And for 5000 bit of data, 5000 bit divided by 10 power 7, it will be simply 500 microsecond. So transmission time of first packet is 500 microsecond. Transmission time of second packet is again 500 microsecond. So 500 microsecond is the transmission time of first packet. So transmission time plus propagation time, you add them, you will get 520 microsecond. So in 520 microsecond, sender router R1 has received first packet. So in 520 microsecond, first packet has been received by router R1. Now router R1 will not stop. It will start processing, because 35 microsecond it will take for processing. So 520 plus 35, what is that answer? 555. So in 555, R1 will start sending the data, okay, to this receiver. So in 555 it has started, so 20 microsecond first bit, and for rest of the bits 500, because transmission time is 500. So 555 plus 500 plus 20, it comes out to be 1075 microseconds. So in 1075 microsecond, this receiver has received first packet. I have written here, first packet has been received by receiver. Now what has happened, see this. So in 520 R1 has received, in 1020 entire data R1 has received. So second packet reached R1 in 500 microsecond. 1020 minus 520, that is 500 microsecond. And you can say like this also, forget about everything, simply say like this. So if channel is idle, or you can say if channel is empty, nothing is there, then you will consider TP. If something is there, you will never consider TP. That is the basic thing. So TP I will consider for the first time. Now next time I will not consider TP, because sender is sending the data, it is not idle. Okay, so after 5000 bytes, it has not stopped. It is still sending the data. So next 5000 bytes will need only 500 microsecond. Why 500 microsecond? Because 10 to the power 7 bits per second is the bandwidth. 5000 needs only 5000. 5000 bit data need 5000 bit divided by 10 power 7. It will be 500 microsecond. So 500 microsecond in next 500 microsecond, second packet will reach R1. Please let me know if anybody is having any doubt till here.
Understood, sir.
Yes, good. So now second packet only need 500 microsecond to from sender to this router. So now after in 1020 microsecond, R1 has received the second packet. I should say like this, because entire data reach R1. So second packet is reached at R1 at 1020. Now R1 will not stop. It will process it. So processing need another 35 for the second packet. It will need another 35 microsecond. So 1055 microsecond. So I will say after 1055 microsecond, this router R1 will start forwarding the second packet. But now see properly, R1 has finished sending the first packet at what time? What I will say, see this. R1 started sending first packet at 555. Now, and it has transmitted for the next 500 microsecond. Now, forget about 20. Please see this. 555, at 555, it has started forwarding the first packet, and it will forward till 500 microsecond only, because in 500 microsecond it has put entire data on this line. So now it has to stop. So it will stop at 1055. And why it will stop? Because it has finished transmission of the first packet. But second packet will be started at 1055 at the same time only. So directly indirectly, I will say R1 has never stopped. It will keep on sending the data. So it's just like that, na. So a train will be departed at 4 p.m. from Delhi for the Bombay, and at 4 p.m. only you decided that I want to put 20 bogies more to the train. So now no extra delay, no problem. So at 1055 only, it has started forwarding the second packet also. So no extra delay will be there. So just like a train, it will keep on going. So for from 1055 till what time it will transmit? So 1055 plus 500 extra, that will be 1555. So at 1555, R1 has stopped sending data because everything has gone. Now plus 20 will be done because of propagation time. So what I will say, at 1075 microsecond, receiver has received the first packet, and next packet will come in 500. So it will be 1075. I think now it should be crystal clear in everybody's mind.
Yes, sir.
Yes, sir.
So okay, no doubt now.
No, sir.
Okay, then that's good. So please take snapshot. I will jump to the next slide now.
Okay, sir.
Okay, so if still somebody is having any doubt, you can watch this recording. You will get more clarity what exactly I was saying and all. You will get it. Okay, now. So now good news is that okay, you have taken the snapshot. Okay. Yeah. So now good news is that transport your physical layer is over. Okay. Now we are going to start data link layer. Data link layer. Actually, physical layer is very huge, but it is not in gate syllabus. That's why I have not considered that. And the numericals and all what I have considered that are very, very important, and they will be asked in gate again and again. Bit rate, baud rate is very important. Okay, and this type of questions has been asked in already in gate. Delay type of thing. Okay, propagation time, transmission time, and so on. They were all the part of physical layer because they are related to signals only. We have completed that topic. Now we are going to start data link layer. Okay, so the most important topic in physical layer was this delay topic. Many times question have been asked. Okay. This delay or latency, propagation time, transmission time, queuing time, processing time. You should know all these things very, very precisely. Okay, and sometimes they have asked bit rate, baud rate also. Okay, and they are basic concept: throughput, bandwidth. Okay, the delay. So all these things I have completed. So you can watch the summary and all in your recording. So I will not unnecessarily summarize the things. It will waste our time. So time is precious. So we should start our next layer now. Okay. So next layer is data link layer. So data link layer, many functionality I have shown you. Like it was. Error detection correction is there. Okay, and then flow control, error control, access control, and so on. Many functionalities. So one by one we will study. So data link layer, what was the uniqueness of data link layer? Every layer was adding header, but data link layer is adding header as well as trailer. To what? Datagram. Datagram is, again and again I am repeating, datagram is packet of network layer. So packet of network layer is received by your data link layer. So now data link layer, to this datagram it will add header as well as trailer. So this resulting packet is known as frame. So header, it will contain physical address of sender and receiver and so on. We will study that later. But we will consider trailer first. So why this trailer has been added? Why this data link layer is unique? Because it has added both the things, header as well as trailer. Every layer is adding header, but it is adding header as well as trailer. So why trailer is added? Trailer is added for error detection and correction. Error detection / correction. So trailer is added for this. So first we will consider this error detection correction, and then we will shift to other topics like framing, how framing is done, and so on. Okay. So error detection and correction. So basic concept. What is an error? Error means, simply I will say, if data received is not same as data sent, then error has occurred. Very simple definition. If data received is not same as data sent, then we say error has occurred. Then we say error has occurred during transmission. So software engineering is not in your GATE syllabus, but in software engineering we say error means deviation from normal behavior. What is the normal behavior of software? That is not doing that. It is deviating from the normal behavior. That is the error. So this is the deviation from the normal behavior. The normal behavior was what? Data sent should be what? Exactly the data received. So data received should be what? It should be exactly same as data sent. Data sent and received should be same. Na? That is the normal behavior. But now you are deviating from the normal behavior. What is the deviation? Data sent, data received is not same as data sent. So we will say error has occurred. Are you getting it? This is the basic definition of error. Now error is of two types: single bit error and burst error. Let me jump to the next slide. Please take snapshot. Okay. So next is two types of error. Two types of error: single bit and burst error. Okay, single bit error and burst error. Single bit error means only one bit. Error in only one bit. Burst error means multiple bits. So what do you think? Which is more likely to occur? That means which probability is more? Single bit error or burst error? So you might say, sir, single bit error is more prominent or more easily to occur than multi-bit error, but no, it is a different scenario. Multiple bits are affected. That means burst error are more common. They are more common. Okay, and single bit error are very, very rare. Why they are very, very rare? So for example, you can consider a numerical, you will get more clarity. Okay, so for example, write a numerical, or okay, let me write it. Take the snapshot, I will jump to the next slide. I am showing you why this is rare and why this is more common.
Copy, sir.
Okay, yeah. So I am saying that data rate, or you can say bandwidth, is 1 Mbps. Data rate 1 Mbps means they are now saying precisely that 1 Mbps is the data which data rate means we are sending data at 1 Mbps, or throughput is 1 Mbps. If they say bandwidth, they can say bandwidth also, but it will be a confusing term. Okay, they are saying data rate means precisely 1 Mbps data is transmitted. That is the basic thing. That means throughput is given as 1 Mbps. Data rate is 1 Mbps. And they are saying noise came for 1 millisecond. 1 millisecond is really very, very less amount. These are mathematical terms actually. 10 power minus 3 second. This is very less amount. Please try to imagine the things. 1 second is very less for us. No? For humans, 1 second is very less. What about 10 to the power minus 3 second? It is really very, very less amount of time. Noise means unwanted signal. Unwanted signal. Like some motor vehicle came, like I'm taking your class and some car or some truck go from a road, and I will say that noise is coming. So like that, na? Noise means unwanted signal. So I'm saying noise came for only 1 millisecond. So now see how many bits will be affected. So how many bits will be affected? That is very simple. Noise is for 1 millisecond. Data rate is 1 Mbps. So in 1 millisecond, how many data bits will be transmitted? 1000 bits will be transmitted. So 1000 bits will be affected. So for 1 bit to be affected, 1 microsecond noise, that is really next to impossible. Generally, when truck will cross, it will take 3 or 4 seconds. Rather, I'm saying very less 3 to 4 seconds. It will take, say, even 40 to 50 seconds it will take. So lots and lots of bits will be affected. So it is very rare that only 1 bit will be affected. Are you getting it? So this kind of very small numerical they can ask, like data rate is 1 Mbps, noise came for 1 millisecond, how many bits will be affected by noise? 1000 bits will be affected. Any doubt here?
No, sir.
And just for sake of completion, I can say data rate is 10 kbps and the noise came for 30 millisecond. How many bits will be affected? So in 1 second, 10,000 bits. So in 30 millisecond, how many bits will be affected? So it will be 30 into 10 power minus 3 into 10 into 10 power 4 seconds bits. Please let me know if anybody is facing any difficulty here. So 3000 bits are affected. Oops, some mistake is there. Yeah, please speak again.
30 milliseconds. The noise you have written 30 milliseconds.
So 30 into 10 power 3, 10 kbps, na? So 10 into 3. So it will be 300 bits. Please see now. Any doubt here?
Done, sir. Understood.
Okay. So 300 bits will be affected. Okay. So more likely to occur. Which is more likely to occur? Multi-bit error. Single bit error is very less likely to occur. Okay. And in the previous class also, rather in the first class I have told you, in the previous lecture also I have told you that which is more efficient, error detection or correction. Error detection is much more efficient. That means the receiver will simply detect the error and sender will resend the data. Okay, but doing correction is much difficult. Okay, because you have to find the position of the bits where it has occurred and so on. So you have to consider many permutation and combination, and it will simply waste our time. So error correction is not efficient way. Error detection is efficient. So let me write it. Take snapshot. I will jump to the next slide.
Done, sir.
Okay. So error detection is more efficient. Error detection is more efficient than error correction. Error retransmission. Error detection and retransmission is more efficient than error correction. Okay, because it will simply waste our time. No? That's why. Error detection and retransmission is more efficient than error correction. Okay, so I think time is up now. So from here itself, we will start our next class. Okay.
Yes, sir.
Okay, sir.
Yeah. Okay. So yeah. Okay. So in the next class, I think sir will tell you. But today I have from 8 to 10:30 discrete mathematics. So please join that class also. Okay. And graph theory is I am covering graph theory. So it is very important topic. Okay. So mostly you will find 1 or 2 questions from this. Okay. Okay. Then I will wind up the class here itself. We will start from here. Okay.
Okay.
Yeah.
Thank you, sir.
Okay then. Bye bye.